Hi, I'm talking a little bit today about two-sided hypothesis testing. So you'll see here I have a situation where a nursery owner claims that recent drought stunted the growth of 22% of evergreens. A botanist claims that they examined 1,100 and they found that 268 showed signs of stunted growth. So we have our null here, which is that 22% had stunted growth. Our alternate here is that it just wasn't 22%. It can be greater or it can be less. So you'll notice what I did here was I calculated my statistic. My statistic was about 24%, 24.36. I also built a sampling distribution based on my null hypothesis. Because again, we're trying to find the likelihood of getting the statistic we got, assuming that our null is our parameter. So we're assuming this is true. And if it is true, then what's the probability of getting the statistic that we got? I calculate the standard deviation here, again, using my null, 0.22, multiply it by 0.78, divide by my sample size, square root. I got a standard deviation of 0.01249, and I decide that I'm just going to go with the first three digits for the sake of what I'm doing. Now, I graphed my statistic here, 0.246, on my sampling distribution. Again, my sampling distribution is based on the parameter that I'm assuming for my hypothesis test. So I got this statistic. And you'll notice on each end here, I have 5% colored in at the high end and the low end. That's because for a two-sided test, you're rejecting the upper 5% as well as the lower 5%. So you're really only accepting 90% of the possible statistics here. Now, based on where I colored, it looks like my statistic is really close to that rejection zone. So I might be rejecting my null hypothesis. That's why I like to draw this out. It gives me an idea going in how close I'm going to be. So what I'm going to do is I want to figure out exactly how many standard deviations away I am. So here's what I'm going to do. I'm going to find the z-score of this. So I'm going to take my statistic, subtract the mean, or my assumed parameter, right? Divide it by my standard deviation. So I'm going to do that right now. Then I'm going to divide it by 0.012, good. And my test statistic is about 1.97. So it's telling me I'm about 1.97 standard deviations away from my parameter in the positive direction. Now here's the thing with a two-sided hypothesis test. It's not just about finding that particular statistic. It's about finding a statistic that extreme. So not only am I concerned about finding a statistic 1.97 standard deviations away in the positive direction, I'm going to carry that as well to the negative direction. Because with a two-sided test, you're concerned about getting an extreme in the upper end as well as the lower end. Oops, didn't want to do that. So I want to figure out the probability of getting a statistic 1.97 or higher and negative 1.97 or lower. That's the key to one of these hypothesis tests. Now I want to find out the probability that I could get something less than 1.97. So I'm going to use, let's see, norm CDF. Recommend you would do the same here. I'm doing this based on z-scores. And I get here 0.024. Now that also tells me if I did it going positive, I'm going to get the same value. But if you don't believe me, you can do norm CDF, and then do positive 1.97, upper bound of 9999, based on z-scores. So I'm going to enter in 0 and 1, and I'm going to find that 0.24 of my statistics, 0.024 of my statistics could be 1.97 or higher. So if I add up these two percentages here, essentially what you're doing is you're doubling the initial one. You can add them both up. And you notice you get a value that's really close to your significance level here. I get 0.048. It's really close to my significance level, but it is less. 0.048 is less than 0.05, my significance level. So because of that, I can reject my null hypothesis. If I just did it based on one direction, going with that 0.024, I wouldn't reject it. However, because this is two-sided, remember, you're going to be doubling that p-value. You're going to be doubling that probability of finding that statistic or higher, because you're also concerned about finding that or lower. That's the key to a two-sided test. You want to double that because you're looking for the probability of finding a statistic that extreme in either direction. That is the key here. So I just wanted to review that quick because it's really typical. A lot of times people just want to take the p-value based on the one direction they're determining here. But remember, for a double-sided test, you want to double it because it's the probability of finding something extreme in the high direction as well as something that extreme in the low direction. Hope this helps.